The final transformation we're going to cover is called a dilation. And a dilation is basically a transformation in which a figure is enlarged or reduced with respect to a fixed point, which we call the center of dilation. So this final transformation that we're covering does not maintain isometry. So a dilation is the one transformation for us that is not a rigid motion. So it doesn't create congruent figures, but what it does is it creates what's called similar figures, and we'll talk about that in the next lesson. Okay? So how do we enlarge or reduce a shape? Well, we need to have what's called the scale factor, and it's going to be the ratio of the lengths of the corresponding image to the pre-image. Okay, so this scale factor is going to tell us exactly how much larger or how much smaller our image is going to be in relation to the original figure, the pre-image. So the two things that we need to know when we create our dilation is the center of dilation, so what fixed point are we, getting bigger or smaller in relation to, and of course the ratio, which is the scale factor. And the scale factor, we typically use the letter K for this, and you have two scenarios. We can either get bigger or smaller. So if K is greater than 1, then this is an enlargement, so it's going to get bigger. If K is between 0 and 1, then it's a reduction, meaning it gets smaller. And then finally, it is possible for K to be negative. So if K is negative, then what happens is the dilation is going to be also a 180-degree rotation. Okay, so the dilation itself is actually very, very easy to compute. We're going to do the construction in class, so let's go ahead and skip over to the back side and just talk about actually how to conduct the dilation in the coordinate plane. So the dilation, of course, can be written out like you have a dilation with scale factor, it's whatever. But for example, dilation with scale factor 5, it's the same thing as having this notation capital D and a little 5 in the lower right hand corner as a subscript. All right? So how do we conduct a dilation? Well, the scale factor 5 is your K, so the K is that subscript. And to do the dilation, you basically just take your original point x, y, and you're going to multiply K times x and then K times y. So it's very, very straightforward. All you're doing is multiplying. So if we take a look at example 2, we're drawing the image of the triangle with these vertices PQR under a dilation with scale factor 1/3. So this K is 1/3, right? So I'm going to go ahead and start by drawing in my pre-image. And there's my Q and there's my R. Right? And because I know it's the scale factor is 1/3, this triangle is going to shrink, right? It's going to get smaller. And before I forget, the scale factor is always with the center of dilation, or sorry, the dilation in a coordinate plane, unless otherwise noted. And for us, it's always going to be the origin. So if that wasn't really clear, our center of dilation is always going to be the origin for our purposes. It could be elsewhere, but we're just going to make sure 0, 0 is our center of dilation. And we'll see how that's important when we do the construction in class. All right, so coming back to this. So if my scale factor is 1/3, to do the dilation here, d of 1/3, all I'm going to do is take p, right, that negative 6, 6, and to get p prime, I'm going to do 1/3 times negative 6, comma, 1/3 times 6, right? Super simple. All I'm doing is multiplying. So p prime is going to be at negative 2, comma 2, right? Oh, and then I can do the same thing to find q prime and r prime. So again, just 1/3 times negative 3, comma, 1/3 times -3. So then Q prime is at -1, -1, right? Finally, R prime. Let's do the multiplication one more time. And then we're going to get R prime at 3, 0. All right. So when we draw this will also obviously not be an isometry, so it's going to be smaller. It's not going to be congruent, but it should be similar, meaning it should have basically the same shape, even though it's not the same size. So when we do our drawing here, and I'm going to do this in red, we should see the same type of shape happening. So there's my P prime, there's my Q prime, and my R prime. So you guys can see it looks pretty much the same shape, just shrunk down. And that's a dilation, and that is it. So we'll continue doing this with our constructions in class and practice this, and then we'll talk about similarity in the next lesson. All right. Thanks for listening.